Hello all, in this video I am going to discuss about the second assignment question. The question was like this. The university believes that the standard deviation of height for students in MBA class is 0.81. However, a researcher in charge of the study believes the standard deviation of height for the school is greater than 0.81. So he took a random sample of 60 students and found that the standard deviation of height of the sample is 0.98 with a significance level of 5%. Test the validity of the claim made by the researcher. So this is a typical case of hypothesis test for single population variance. So this is usually tested using chi-square test. It is the chi-square test which is generally used in the case where you need to conduct a hypothesis test for a single population variance. So the null hypothesis here is the population variance is equal to uh, the hypothesized value, that was 0.81, and the 0.81 square, because 0.81 is one is standard deviation, right? The standard deviation square is your variance. So sigma square equal to 0.81 square, that is your null hypothesis, and your alternative hypothesis, sorry, it's supposed to be h1. H1 is sigma square greater than 0.81 square. So so this is a typical case of a one-tail test, and that too right-tail test, right? So the level of significance that was given as 0.05, right? And coming to the test statistics formula, the chi-square test statistics formula is like this. N minus 1, that is the degrees of freedom. N stand for sample size multiplied with S square. S stand for standard deviation. S square is nothing but the variance. So it is a small s, so that basically stand for the sample variance. So S square stand for sample variance divided with sigma square. Sigma square is the population variance. So if you replace these symbols with those numbers, you will get in the numerator, you will get uh, your degrees of freedom is 59 into your sample standard deviation was 0.98, that squared is your variance. So you will get a value 56.66. that will be your numerator here, and the denominator is nothing but the population variance square, sorry, the population standard deviation square, that is the population variance. So that is 0.66. So if you divide this value by this value, so you will get the test statistics, and that is nothing but 86.36. So now you have the test statistics with you. Now let's find out the critical value. So the critical value, you can obtain it directly from Excel. Uh, so if you put this formula here, I mean equal to chi-square inverse equal to chi-square dot inverse dot rt. Rt stand for right tail, and your probability is nothing but the level of significance, and your degrees of freedom here, 60 minus 1, that is 59, right? So let us see what is um, the critical value associated with these parameters. So it is 77.93. So that is your critical value, and the decision, if you go by based on the test statistics versus table value or critical value, if your test statistics is greater than table value, then you reject the null hypothesis. So here your test statistics was 86.36 and your table value was 77.93. So your test statistics is greater than table value, so you reject the null. And we basically says that the claim made by the researcher was right. It is actually the standard deviation of height for students in MPA is actually greater than 0.81. You reject the null hypothesis that it is equal to 8.81. So, so this is your, the solution for your second assignment question. So I will get back with the third uh, question solution as soon as possible. Thank you.